All right, this lesson is on finding the domain and range of a relation. If you don't know what a relation is, please go back and look at the videos for relation notation and also look at identifying functions, as functions are just special types of relations, and you'll hear me talk about functions in this video. What is a domain? Well, a domain is the list of all possible x values. You look at the graph or the table or the set, and you're looking at what are all the possible values of x that I could use. We also refer to these as our inputs, and so therefore it's the list of all possible x values or all possible inputs. The range, on the other hand, looks at the list of all possible y values. Our y values are also known as our output when it comes to relations. We refer to them as outputs more specifically when we're dealing with relations. Now, how can you remember this? Well, I use the acronym here DXI as well as RYO because we can all count the alphabet, right? You can all say the alphabet back to me. And we know that x comes before y when we're talking about x values and y values. In fact, in ordered pairs, we always go x, comma, y, and so on. X comes before y alphabetically, so we know that that one typically comes first. But if you look at the other words that are associated here, we notice that we also have inputs and outputs are referred to. Well, I comes before O alphabetically, and now we're calling them domain and range, and D comes before R alphabetically. So when you're talking about domain and range, you're like, crap, which one is domain again? Well, that is my x values because x comes before y, in the same way that D comes before R, domain comes before range. All right, so that's what we're looking for. Let's see how we actually do it. All right, take a look at these ones here, and let's just identify them. In example number 1, we have a relation g of x, which happens to be a function here, and we want to look at what are all the possible x values that are allowed to occur. Well, if I look at any x value, pick any one that you want, and I pick, let's just say, -2 here. All right, here's an x value, -2. If I trace that up to my relation, I see that I get an output. Therefore, I can use an input, an x value of -2, because it will give me an output. I pick the value of 1. If I just pick 1 and I trace it up, once again, I get an output. And therefore, there is an input value of 1 because it will generate an output. But what if I pick a value like 6? Well, if I pick this value 6 and I go up or I go down, I do not get an output. Therefore, 6 is not part of my domain. It's not an x value that I can choose, because if I use that x value, I will not get an output. So I'm looking at what is the lowest input that I could put into this relation and get an output, and what is the highest input that I could put into this relation and get an output, and can I use everything in between? Well, in this case, my lowest is -2, and my highest here is 4. Notice it continues, and I can use any of these values in between, all the way from -2 all the way up to and including 4. And if you notice, what I just drew is a compound inequality. A compound inequality that has a minimum, let me get my other color here, that has a minimum of -2, and it can be equal to that, and it has a maximum of 4, and anything in between. All right, let's take a look now at my y values, and I'm going to use green here for this. We'll use Christmas colors. And look at the list of all possible y values. Well, my lowest y value, if I notice right here, and I trace this over, that's the lowest my relation goes. It's right here, and I'm using a solid point because I do have an output when I have a -1. That's my output right there. And it's a solid point there, so solid point. What's the highest that it goes on my y-axis? Well, if I look, the very top happens to be right on the y-axis. All right, it's right there. And I can have an output for anything in between. Now, notice here I get outputs this way and this way, but down here I don't get any that way. I only have outputs to the right here, and that's okay. As long as I have at least one output, it is a possible value of y. And if you notice, my minimum there is -1. Oh, I'm going to go back to white for a second. My minimum there is -1, and it can equal -1, and my maximum there is 3. And so I see I've got a range here that goes from -1 up to 3. That's the list of all possible y values or outputs for this relation. All right, let's take a look over here at the next one. In this next one, we have something unique. In this case here, now I've got some arrows. You can see an arrow there and an arrow there. And that means it continues on forever in the direction that it was headed prior to leaving the graph. Well, take a look at what was happening. In this part right here, it was going to the left. So when I'm talking about x values, it's going to continue going to the left forever, which means it will hit every single x value in the negative direction. And if I take a look here, it was also headed to the right when it left this direction before that arrow. I'm going to draw that little arrow on there. All right, that means it will forever go to the right, hitting all the possible positive x values. And therefore, when I go to list my domain, I'm really looking at the fact that x can be any value. It will hit all of them. What about my range, however, though? In my range here, I notice that, again, going to the left here, it's not just going left, but it's also going down. It doesn't look like it's going down steep because it's not, but it is going down, which means this will continue to go down forever. All right, it will continue to get lower, and it will go lower and lower. It'll take a long time to get really, really far down, but it has forever, and so it'll eventually get there. Likewise, this one here, we notice it's also going up. It's not flattening out. All right, it's going up, and therefore we will assume that it goes up forever. You have to assume that it's going to continue doing what it was doing prior to leaving. That's what an arrow tells you. All right, so in this case here, we find that y is also a list of all possible real numbers. It could hit everything. Now, I use notation here to represent my domain and range that you're familiar with. We notice we have compound inequalities showing our integral notation there, and we also have just a list of all the possible x values and y values using our all real numbers symbol. Those are things you're used to. But what we want to do is we want to talk about a certain type of notation that we will use to write the domain and range. That notation is our interval notation. All right, interval notation is a special notation that we will use in order to write all of these compound inequalities and the statement of x equals all real numbers that you see on the left here. And I'm going to go ahead and put them up here. And I want you, once I put them up here, I want you to pause the video and I want you to then see if you see a pattern. There's the interval notation for the first 4 compound inequalities. Again, pause it, see if you notice a pattern. Coming back in, I hope that you did notice a pattern. In the pattern, you notice I've got 2 different types of brackets, and hopefully you identified when they are used. Well, the first type of bracket that I'm going to talk about is a closed bracket. Closed brackets, we've seen closed before. All right, closed brackets are these ones right here. They look like square brackets. Closed brackets are used whenever I have a less than or equal to, because it's allowed to equal that number that the bracket is next to. We've seen this before when we see closed points, just like this, and we've seen it before when we've seen closed lines, represented on our graph as a solid line. That's what a closed line was. All right. These values are all going to be used anytime on the graph we can equal that output, where you can actually get an output at that spot, and you'll notice to use that whenever again you see a closed dot on the graph or a closed line on the graph. All right. The second type of bracket that you notice there is called an open bracket. Our open brackets look like this. It almost looks like an ordered pair, but when we're talking about interval notation, it's not an ordered pair. This is used when it's just less than. We've seen these before with less than when it's an open circle, and we'll also see it on the graph represented by an open line, as we will come to know that open line as an asymptote. And I will talk more about asymptotes later. All right, so that's how we're going to identify it for right now. There's one more instance where we use an open bracket, and in this case here, it's down at our x equals all real numbers. In order to represent x equals all real numbers, that means that it goes forever in the negative direction and forever in the positive direction. In mathematics, the symbol infinity is used to represent forever. But 2 positive infinities doesn't make sense because one's supposed to be my minimum, one's supposed to be my maximum. And so therefore, this is supposed to go forever in the negative direction. And I always show the one on the left as a negative because the number on the left is always my minimum value of my interval notation, and the number on the right is always my maximum value. So negative infinity would be my minimum value, and positive infinity would be my maximum value. Now, can you ever equal those? No, you cannot. I can never reach infinity, so I need to use an open bracket. All right, so that's again where we'll see our open brackets whenever we deal with infinity. But how do we recognize that on a graph? Well, we recognize that we are going to be dealing with open brackets when we have an arrow. All right, you'll see arrows to the left, you'll see arrows down, and sometimes you'll see them going left and down. All right, that's typically negative infinity. Obviously left when you're talking about domain and down when you're talking about range. Likewise, for positive infinity, we'll see it going to the right, we'll see it going up, or sometimes we'll see it going up at an angle. All right, again, it's just if it's going right when you're talking about domain and if it's going up when you're talking about range. And so we'll see this when we have arrows involved as well. All right, so you will use open brackets when you have an open circle, an open line known as an asymptote. We've used those when we've graphed inequalities, and an arrow. Now, let's go ahead and use this interval notation and let's start identifying, all right, some of our domains and range with the interval notation. On this first graph here, if you move across, and you can use one of our tools that we used last time, our spotlight. All right, we had this here, and you could move it across just like you did when we were determining if it was a function using our vertical line test. And as I move across, I can see what is my first x value that I come to, and I notice that is -3. And then I'm going to continue on, and what is my last x value that I hit on this graph? And the last x value is 3. And so I know that for my domain, it's going to be -3 to 3. Now, could it equal at that time? Well, at -3, it was a solid line, and therefore it is a closed bracket. At +3, it was a solid line, or curve, actually, and so I get that. I can use the same tool of the spotlight to calculate my range, just coming up from the bottom now. Coming up from the bottom, what's the first y value that I hit? Well, -3. And the last y value that I hit is also +3. Hey, just like my domain. So again, -3 is my minimum, +3 is my maximum. And was it a solid curve at that spot? Yes, it was. So closed brackets. Let's take a look at the next one. Again, I'm going to use my tool here. All right. Coming from the right side, I'm again looking at this right edge of this gray box you see in front of you. Coming from the right side, what's the first thing that I hit? An arrow. That means I'm going to start with infinity. It goes on forever in that direction. And continuing on, what's the last thing that I hit? Another arrow. And so for my domain, -infinity was my minimum, and +infinity was my maximum. Those was the first thing I hit was an arrow, last thing I hit was an arrow. And I cannot equal those, so I use open brackets. All right, let's go ahead and do our range now. Range starting at the bottom, coming up. The very first thing I hit on my graph is an arrow, so it's going to go down forever. And continuing on, the last thing that I hit is an arrow. And so it's going to be the exact same thing of going from -infinity all the way up to +infinity, essentially all real numbers. Let's take a look at the next one here. See, I have modified that. That red circle represents an open circle because I wanted to show what that would look like. And let's get our domain. Coming from the left and moving to the right, the first thing that I hit coming in here is a closed dot there at -2. All right, closed dot at -2. And if I continue on, the last thing that I hit is an open dot, or an open circle there, an open point, at 4. All right, so I know in this case my minimum is -2, my maximum is 4, but at -2 I had a closed dot, so I'm using closed parentheses, but at 4 I had an open dot, so I'm going to use open parentheses. All right, let's do our next one here. All right, I'm going to do my range now, so I'm going to start at the bottom and move my way to the top. First thing I hit, closed point there at -4. And last thing I hit is open point there at +2. So I'm going from -4 all the way up to +2. Again, it's closed at -4 because it was a solid point, and open at +2 there because it was an open point. Let's get a few more examples. Feel free to pause the video, see if you can get these on your own, and then come back and let's see how we're doing. All right, on this one here, the first one, I'm assuming you paused it at this point. I'm going to come from left and move my way right. First thing I hit, arrow. So it starts at -infinity and keep going. The last thing I hit is arrow. So it ends at +infinity. So -infinity to +infinity. The domain is all real numbers. All right, let's do my range now, starting at the bottom. I'm working my way up. First thing I hit is, well, 2 arrows. But it doesn't matter that I hit 2 arrows. As long as you hit 1 arrow coming up from the bottom, it's going to be -infinity. And if I keep going, what's the last thing that I hit? The highest point on my graph is, right there at 4. And it's a solid curve right there at 4. So I'm going from -infinity. This graph will go down forever. But the maximum point is 4. And it will be able to equal 4. See how you did on E. All right, starting at the left and moving right. Nothing, nothing, nothing. All right, but then all of a sudden, there it is. There's my graph. It starts at 2. Solid curve there. So close bracket at 2. And I continue, and what's my furthest point there? All right, furthest point's at 4. Notice I have an open circle down below, but I do have a solid curve up above. There is an output. The output is 1. All right, so in this case here, my domain goes from 2 to 4, and it can equal 2, solid curve, and it can equal 4. It equals 4 up top, not down below. All right, now check to see how you did on your range. Starting at the bottom, coming up. First thing is open circle at -3, so a minimum of -3. It's going to use an open parenthesis or an open bracket. And last point there, maximum was 2 with a solid point. So -3 as a minimum, 2 as a maximum, and it could not equal -3, but it could equal 2. What about F? Maybe you got stumped on F. But let's take a look at F. As I come across, what are my X values? Well, the first thing I hit is closed point at -2, but it doesn't continue. But I do hit another point at -1, and I hit another point. Where's my next point? There it is, at 4. All right. So for my X values, I saw I had a point at -2, I saw I had a point at -1, and I saw I had a point at 4. But can I use interval notation? No, I can't, because there's no interval. Interval means there's a minimum and maximum, and everything in between is included. In this case, it's just those values, so I have to use something different called set notation. And I mentioned this briefly in my other video, and I'm coming back to it now. Set notation, oh, that is an ugly one. I'm going to try that again. All right, set notation uses these funky brackets. It's our third and final brackets, and those brackets say that I'm just using a set of numbers. In set notation, you should list all of the values of X without repeating any. Notice there were 2 points when X was at -2, but I only put -2 once in my domain. Also, the values should be listed from lowest to greatest. All right, it should be -2 as our lowest, then -1, then 4. So it should go from least to greatest. Let's try and go ahead and get our set then for our range. All right, so again, starting at the bottom, coming up from the bottom, the first Y value or output I hit is right there. Hold up, I'm going to need a reference to figure out what that is. Ah, it's -4. All right, come up a little higher. I hit a point there at -1. I hit a point at 1, and I hit a point at 2. All right, and those are all my points. So I had -4, -1, 1, 2, and it was not an interval. It's just a set of numbers that are being listed there, and so I use set notation. Set notation also comes in handy in other cases. I'm going to jump over these ones. I'll come back to that. Set notation also comes in handy here when I'm looking at a table. If you're given a table for your relation, it doesn't tell you specifically that you have a graph. All right, so you don't know what other points are involved. I don't have an expression here to find other outputs given these inputs. And even though I may recognize a pattern, I don't know if this one is like the one we just saw in F, where it's just a list of points. I can't assume. All right, so when you have a table, no graph, no expression to say how I'm getting from X to my output, my input to output, I merely list the values that are given to me. The domain for this table would be -3, -2, -1, 0, 1, 2, 3. That's it. I just list my inputs. On my outputs, it's a little bit more challenging because I want to start with my minimum, which in this case is -4, then -3, 0, and 5. But notice, many of those outputs are repeated, all right? And I only list them once. I only list the output once in set notation, and it goes from least to greatest. All right, I want to take a look at a few more graphs here. These graphs here, look at what we'd see are asymptotes. Now, all of a sudden, we come across our dotted line or our open line. I mentioned it earlier. This is called an asymptote. All right, it's spelled like this, asymptote. All right, and it's this dotted line right here. That asymptote is representing a boundary point, a boundary line for the curve. That curve is going to come down and it's going to get infinitely close to, but never touch the asymptote. It will get so close that sometimes it will look like it's equal to, but it is never actually equal to that. So let's see how to do the domain and range using the asymptote. In the same way that we did our graphs before, I'm just going to come from the right side here using a vertical line to see what I hit first. First thing I hit in my graph is an arrow, so I know it's going to -infinity. Last thing I hit is an arrow. So my domain, just like before, is from -infinity to infinity. All right, but what about my range here? Coming from the bottom, the first thing I hit here is this dotted line. It is an asymptote. And where do I hit that dotted line? At -2. That's saying my minimum is going to be -2. And then I continue up and see what my maximum is, seeing that my maximum here is represented by an arrow, so positive infinity. So minimum of -2, maximum of infinity, and an asymptote being an open line says it's open parentheses because it will never equal -2. Now you try for the second graph. Go ahead and pause the video and try it yourself. All right, coming back now, let's see how you did. Again, using my vertical lines, I'm going to come from the left and move to the right. Seeing the first thing I hit on this graph is an arrow, so negative infinity is my lower boundary, or minimum. And the last thing I hit is an arrow again, seeing that I am once again going from negative infinity to positive infinity, so my domain is all real numbers. But what about my range here? Coming from the bottom, this time first thing I hit is an arrow, negative infinity is going to be my minimum. But the last thing I hit looks like an arrow if I stop there, but really it's that dotted line. That's my asymptote. All right, my asymptote here is where y is equal to 3. So I'm going to have a minimum of negative infinity and a maximum of 3, but the graph will never equal 3. The one over here to the right, I'm not going to do domain and range for this because it's actually very complicated as we've got several things going on. But I wanted to show you a fun graph where we've got 4 asymptotes in this case, and it's sectioning off my graph into 5 different spaces. And you'll see graphs like that more as you head into the high school. All right, I said I was coming back to this one, so now looking at an expression. If I'm finding the domain or range of an expression, you really want to just look at what are all the possible x values or outputs that you can get. You can go ahead and graph this relation, and then when you plug it in, you'll be able to see what it looks like, and you can do it on the graph just like we did. Or you can start to explore some things. I'm just going to explore the domain in this case here for each of these. And I want you to explore some of the impossibilities here with my domain just to recognize, and I'm not going to use interval notation here, I just want you to recognize what the domain can't be. All right? In certain instances, like this first one here in H, you see a denominator with a variable in it. Remember, the key thing when you have a denominator is it can never equal 0. Therefore, in this case, x can equal all real numbers for the most part. However, x cannot equal 3. All right, and that's how I could write it. You're not going to be asked to write it like that. I would basically ask you in this case, what value can x not be? Well, x can be anything except 3. 3 is the one value of x that will make this expression impossible. What about I? Is there any value of x that you can't put in? Well, no. This is just a linear graph. In fact, any value of x, you could put anything in for x that you want. Anything at all. X is going to be all real numbers. In this case, as we've seen before, you could represent that in interval notation going from negative infinity to positive infinity. All right, and then what about j here? In this j, I've got a square root. Square roots, I cannot get a negative. Well, at what point will this be negative? Well, anything that goes beyond 0. Well, at 0, that's when 4 minus 4 is 0. So when x is 4, you get 0. So anything less than 4 is going to make this much smaller. So my domain in this case, x can be anything that is greater than or equal to 4. How would you write that in set notation? Well, that means that my minimum is 4 and it can equal 4, and my maximum can go up forever. All right, and that would be your set notation for this. And that's how you do it with expressions. Most expressions that you'll be asked to identify the domain and range, it's just going to ask you, are there any values of x that aren't allowed in this case? Let's look at our final section now. In our final example, I want you to try and go ahead and do the domain and range for this. See if you understand what we've been talking about this whole time. Pause the video, go for it. All right, coming back in now, let's see how you did. Domain, I'm going to start at the left and move myself to the right. I've got an open circle at -2, so minimum -2, and it cannot equal it. And the furthest right thing is an arrow, so I'm starting minimum -2 to a maximum of infinity, and it cannot equal either. Let's do my range, see how you did. Coming from the bottom, moving my way up top, first thing I hit is an arrow, so negative infinity is where the boundary goes. There's an open circle, but that's not my maximum point here. Highest point right there is 3, and it is a solid point, or a solid curve there. So negative infinity is my minimum boundary, and 3 is my maximum, and it can equal 3. Hopefully you did a good job on that. If you have any questions about it, come see me in class.